All right. So the first thing we're going to do today is basically law of conservation momentum. Law of conservation momentum will be asked for 2 marks, right? So we're going to write it for 2 marks. Let me write it down. So first, you just need to remember the law of conservation first mark is when you write in an isolated system. Writing in an isolated system means that the bodies that we're talking about in this are basically all have forces which are known to us, right? That's how it is. So speaking of that, then just need to remember the second thing you're going to write is that the total momentum before collision is equal to the total momentum after the collision. Okay, so writing this one would just give you 1 mark as well. Anyway, now, so suppose you have these two bodies which have collided. So the general formula for this one would be, so before equals to after, so we can write as m1 u1 plus m1 m2 u2, sorry, m2 u2 equals to m1 v1 plus m2 v2. So this is basically the general formula we're going to apply everywhere, and depending on the situation we're going to change it a bit. Okay, all right, if you guys are all right. Now, so the next thing we're going to understand is that suppose if a question like this comes and they asked a mass m traveling with speed u1 collides, and you can see basically uh, it says which equation is like not correct, right? So it says the collision is perfectly elastic, which means that kinetic energy before should also be equal to kinetic energy after, and we just need to okay, right. After, so we just need to prove it. First of all, obviously when you see the equation, all right, in fact it says which equation is not correct. We'll come back after we've done the elastic one because this relates to that. So just keep it for later. We're going to come back to this in a bit. Okay. All right. Let's go here. So, for example, in the case one, it would be when two bodies will collide and then they separate. So, in this one, it says two solid surface from an isolated sphere x moves with a speed of 6 and in a straight line towards a stationary space. So, if this is m1 and this is m2, so right now its speed is 0. So, this would be u1 and u2 will be 0. It says the spheres are perfectly elastic collision. After collision, sphere X moves with the speed 2 meter in the same direction as before. Sphere X. Okay. So afterwards, they're saying that this X goes in this speed at 2 meters per second. So that would be v1. What is the speed of sphere y? So they want us to find this speed of sphere y. All right. Now, anyway, okay. Now we could have basically done it if we had known the masses. The issue is that now I just want to tell you this important fact that in such a questions we have a different formula, but right now I'm just assuming here as a case one because it's not very related. Suppose this is a mass x and it has a value of 2 kg and it is going at 6 meters per second, and that's u1 in this direction. And there is another mass y which is going in this direction, which is suppose with 2 meters per second, and it has a mass of 4 kgs. So afterwards, basically, this mass y, we don't know where it goes. Okay, so v2 we don't know, but we know that this sphere x basically stops completely, right? So this is not related to the question above. That is a different equation. Anyway, that was pasted wrongly. So what you're gonna do is you're gonna the first step is that you always assign the directions. Okay, and how do we do this? We can take this side as positive. We can say this side is negative because it really depends on the type of question we're solving. But you can always take it this way, or you can also take it like this way. So I'm going to solve this from both types and then see where we can apply that. Anyway, so in this particular thing, we're going to write m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Now, m1 is 2. The initial speed would be positive because it's going towards right. We're going to take this as negative u2 because it's left, and we don't know about the other ones. So 2 times 6, and this would be 4 times minus 2, and this would be 2 times 0, and we don't know where it goes, so it's going to be um, 4 times v2. Okay, so 2 times 6 will be 12, and this is going to be minus 8. This will be 0, this will be 4v2. So 12 minus 8 will be 4, and 4v2. So basically, the answer comes out as 1 meters per second. And the answer is positive, which basically means a positive answer would mean that the object moves to the right. Okay, so which means that if you look at the two bodies, this body we don't know, but now we know that it's going to go here with 1 meters per second, right? Like that. Now, what if somebody had thought that, okay, I'm going to take this side as negatives, then what would have happened? So even if you switch the directions, that doesn't really matter. The end result would be the same. So let's see how. So if we had put it like this, then 2 times it would be minus 6 because you're taking right side as negative, and that would be 4 times positive 2, right? Then this would be 2 times 0, and this would be 4 times v2. So now you will get minus 12, you will get plus 8, 0 plus 4v2. This is going to be minus 4 and 4v2. When you divide it, the answer will be minus 1 meters per second. Now, even doing this, although the answer seems different, but you just need to understand that in this section we have taken negative as the right side, which means the object moves to the right. So the end result, whether you take right as positive, right as negative, does not change. Do you guys understand this? Okay. All right. Zahan, Yaya, Omar, Sohail,
Yes.
Muhammad
Yes.
Khan, Ahmed Aziz, Juwairiya, Khatija. Okay.
Yes, sir.
All right. Okay, you can write this down, please, and then we can go forward. Okay. So now we're gonna go to the next thing. So in case two questions, you would often basically see this word, which when they say two bodies collide and stick together. Now the variation of this word could be like embed. They can also say go together. Oh, wrong spelling. Oh my god. Okay, so go together. They can also say like what can they say? Nothing else other than that. Anyway, so then in this,
So do they call it elastic or inelastic?
what do you mean? Sorry, come again.
Do they call it elastic or inelastic?
No, they would call it nothing. Although it is inelastic, they would call it nothing. Okay. So right now we're not talking about that. We're only talking about if stick together case comes. So in this one, like you can see, it says two frictionless trolleys are moving towards each other along the same horizontal straight line. The mass and velocity is shown. The trolleys collide and stick together. Okay, so when you hear this, or you read this, you should understand that it says what is the velocity after the collision. So after the collision, it means that they have now like stuck like this. They're stuck with each other. And now they might go either way. We don't know where the velocity will be, right? Which they need to find the direction. So again, the same way, we're gonna take either right or left, positive or negative. So let's take it this way. It doesn't really change anything at the end. So this is going to be positive, this is going to be negative. And now we can write it as m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Then what you want to do is you're going to add it. So 2 times 1 plus 3 times negative 4. Afterwards, what happens is when they combine, so you're going to add the masses. So 2 plus 3, and they will have just a single velocity. So just remember, add the masses. Okay. So then you're going to get 2 minus 12 equals to 5 times v. So it's going to be minus 10 equals to 5 times v. So v is going to be minus 10 divided by 5, which is minus 2 meters per second. So obviously this is the answer. But who's going to tell me if it's going right or left?
Left.
Left.
Left. The reason is because we have a negative answer. That would mean that it's going to be to the left, and that would be the answer. Is that clear? Okay. Why? Why, my people? Is somebody waiting? Okay. So then this is this easy if you just follow this particular way. Now in this sort of question, now this is I'm going to give you as homework because this is the same. And how do I know it is the same? Because it would say somewhere that it embeds. Okay, so when it embeds, it means that now it is case 2. You should remember that. Anyway, let's see if I posted. No, I did not paste any other question now.
Sir, embed means to go together or separate?
Go together. Go together.
Okay.
Okay. Wait. Okay. Just give me like 1 second, please. Okay. In fact, you gotta wait one more. Ah, damn.
Sir, what was the answer for the previous question before the multiple choice question?
No,
No,
we'll
you
come back
showed
to
us
that.
an example,
That was
right?
not.
There was a velocity.
I did, but it has a different, different ideology. So we're gonna come back to that. Don't worry. Okay. Now the third case is. Oh crap! What did I do? What did I do? Oh my god! So now, for this one, now if in a case where we say when a body explodes and recoils, okay, explosion and recoils basically means that actually like there has to be like one body initially, and then that body might just go in two parts. So you just need to remember that. Okay, so like a gun or a cannonball, right? A cannonball is fired, the ball goes forward, cannon goes backward. So that's recoiling, or even a gun. So if you play, shooting games, you might realize that when you shoot a bullet, the gun goes up or backwards, right? Because that's how recoiling works. Anyway, so it is a very similar question, but it's obviously a bit tricky. So now it says that a stationary body explodes. So body was stationary initially and explodes into two components, mass m and 2m. Okay, the components gain kinetic energy, and as you can see, and what is the value of this? Now the issue is that to find the kinetic energies, we need to have basically their velocities, which we do not have, right? So it means when the total body was not exploded, it means that it must be of 3m mass and no velocity at all. So this is the condition before. And afterwards, one of its piece has gone this way, the other piece has gone this way, and this is m, that is 2m. So this is what we're dealing in. So again, when this comes, obviously you're going to put the direction. So let's take this direction. So this would be positive, this would be negative. Let's call this V1, let's call this V2. Now, so when you write the equation, you say, okay, m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. You should understand that this is just one mass. So if initially that mass has no velocity, so total momentum is 0. Afterwards, we got 2m and it's going at v1 velocity, and we got yeah, and we got m which is going at minus v2. How do I know this? Because I know that no matter what, when they explode, they're gonna explode in opposite directions. So one goes, if it goes to left, the other goes to right. That has to be the case. So it's going to be 0. So 2mv1 plus m minus v2. So this will go there. It will be m v2 equals to 2m v1. So now if m and m cancels out, so we know v2 would be equal to 2 times of v1, and that's the thing that we should remember. So it means that this is, uh, if this velocity was v1, then this velocity got to be just 2 times of v1. Everybody agrees? Because this is v2. Okay. Now, from momentum, we can actually find the velocity, and then we can use kinetic energy formula. So we want to find the kinetic energy of this one, right? So for x, we can say kinetic energy would be half times mass was m, velocity was 2v1 whole squared. So it's going to be half m 4v1 squared. So this cancels out. What you get? 2m v1 squared. So this is for x. Then for y, we can find it as half mv squared. So it's going to be half. The mass of y was 2m. And then the velocity was just v1's whole square, because that's how it is. Anyway, so this will cancel out. This will be vm v1 square. So you get this. Now what they want is, they want us to find ratio of x and y. So x was 2m v1 square, y was m v1 square. This cancels, this cancels. So what you get? 2:1, which is just c. All right. Let me know if you do not understand this or anything that's confusing to you. I can help you with that.
Sir, from the equation where you labeled v2 equals to 2v1, how we know which one is
Yeah.
x and which one is y?
You can just put it that way. I labeled v1 here, right, initially. So this would be y, this would be x. That's why.
All right, so yeah, I get it.
Okay.
So initial velocity for 0 is for 3, and before it like
That is
explodes.
before it explodes, right? So that's usually he would give you that if it doesn't collide, it doesn't explode yet. So it means that when it does, all the masses are going to go in the opposite directions to each other, like that. Okay? Do you understand?
Yeah.
All right. Is there anybody who did not understand this? Javeria, Khatija, Laiba, Ali Munim?
Clear, sir.
Okay, that's very good. All right. So then for this question, I don't know how many questions. Okay, this one is for you. I don't want to do that. So homework. Okay. So then I'll just explain it to you. You know the principle of conservation. I wrote it. What is the difference between elastic and elastic? You will know that soon.
So what was
And
the answer for previous question?
2:1. C. Okay. Yeah.
Okay.
So everything else you can basically do. So let's see. Now, now the relationship between kinetic energy, and I did not completely write it, and momentum. We just need to learn how to derivate it. So let's try and do that. So kinetic energy basically is given by half mv squared, and momentum is mv. Now both have mv's in them, which means there has to be something. So we're going to make v the subject of this equation, which is going to lead us to momentum over mass, and then we're going to square it. So if I square this and I square this, so we're going to get v squared equals to p squared over m squared. You guys agree? Okay.
Yes.
Then what we can do is we can actually replace this V right into this one. And if I do that, then I'm going to get kinetic energy equals to half m. And instead of v square, I'm writing p square over m square. So one of the m's cancel with the one that is bottom. So this becomes like what I'm saying is that this cancels out with this, which makes it basically equal to p square over 2m, and that would be the kinetic energy equation. Is that clear, everyone? Will you guys be able to remember this? Very easy, nothing, fancy. If you still have any questions, do let me know. Okay. Interesting.
Sir, explain that again. I did not get it.
Okay. So, Mr. Sohail, can I write V as the subject? Can I do that, please? Can I?
Yes.
With your permission. So then it will be P over M. If I square on this side, I will have to square on the other side as well, right? So then V square equals to P square over M square because square multiplies with both of them. Do you understand? It applies to both of them.
Yes.
Is it clear? If you look at this formula, it also has V square in it. So can I put this V square right here?
Yes, you can.
So then half is here, M is here. This V square was equal to this, so I just replaced it here. Then there was
All
one
right, sir. All right.
top, there was two M's at bottom, so I cancel one M with the other M, and I'm just left with 2, 1M, and V square. Okay, do you understand now?
Yes.
Good. Okay, so then we are going to go towards the types of collisions. So the types of collisions basically are elastic and inelastic. So what is the difference between them? I just want to tell you, elastic collision means that the kinetic energy, I'm talking about the total one, is same before and after collision, which means in this case it would be like half m u1 square plus half m u2 square m1 m2 should be equal to half m1 v1 square plus half m2 v2 square. All right, is that clear? But speaking of this, I just want to tell you that when something is inelastic, it means that the kinetic energy, which is the total one, initially, whatever it is, doesn't really matter, is not equal to kinetic energy. It's not same before and after collision. Okay, which means if you want to find that, it's going to be like half m1 u1 square plus half m2 u2 square will not be equal. The two sides will never be equal. Half m1 v1 square plus half m2 v2 square. So they're not going to be equal, which means that you can call that particular collision inelastic. Okay, there is a small tip that I want you guys to remember, and the tip is that I'm just going to write it here. In a case where two bodies stick, okay, embed, or whatever they do, they go together in this case, right, the collision is always inelastic. So please do remember that. This is one thing that you should always remember. The reason is because when they stick, they lose a lot of energy, and that is the reason why we cannot call them elastic. And you will see when we are actually proving it too. Okay. All right. Umar, Wajiha, Yaya, do you guys understand this?
Yes.
Okay. Zahan, are you here? Okay. Good. Very nice. Now, the question then remains, what happens to total energy and momentum? Does it also change or, is not conserved or something like that? No. So in this situation, if it's elastic collision, the kinetic energy is conserved. The total energy is conserved and momentum is also conserved. Because these two are laws, so laws do not break. And kinetic energy is just energy, so it can convert to other form. Kinetic energy in this one, in if it's inelastic, it's not conserved. Total energy is conserved, and momentum is also conserved. So no matter what, momentum and total energy will be conserved because there's a laws, and kinetic energy might not conserve, and that makes it inelastic. Okay. All right. Aman, Ayan,
Sir, can you go up? I want to see the previous equation.
where is Hamad today? Why isn't he here? Okay. Yes, please.
The one you showed
Which
before,
equation?
p square over 2m.
Wajiha. Wajiha, when I've like sent you the link to the Google Classroom as well.
Yes, sir.
So you join that, all right? You join that. You will find these like links where you can find this and you can download the PDF. I think I've explained that to you before or not?
Yes, sir. Thank you so
Okay.
much.
And also the videos, all right? Okay, right. So then let's go forward. Done. Everybody has written it. Should I go forward now? Okay. Now, so for example, in this sort of question, it says two balls of masses m and 2m traveling with initial velocities 2v and v respectively collide with each other head on, as you can see. And after the collision, the ball of mass m rebounds to the left. So they're saying afterwards, the ball m rebounds to the left with the velocity v. And what? What is the loss of kinetic energy? We don't know what happens to 2m, do we? That's not fair, right? Okay. So before we could find the loss of kinetic energy, we have to then find what would be the velocity, v2. We don't know that, right? So again, assign the signs. Okay. This should be plus, this should be negative, right? We would say, basically this question should have been the first question. Anyway, so this is a case one question like that. So you can write this as positive, you can call this as negative, and this would be negative, and we don't know that. We don't know about the other one. So we're going to write m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. So the mass right now is m. This is going to be 2v, and then this is going to be 2m, and that's going to be negative v. So you should understand that. Afterwards, after collision, mass m goes with negative v, and m2, that is like 2m, we don't know where it goes, so we're just going to leave it as it is. So this becomes 2mv, that becomes minus 2mv, this becomes minus mv, and that is plus 2mv2. So 2mv, 2mv becomes 0. This is like minus mv plus 2mv2. This goes there, so mv equals to 2mv2. This cancels out. So V2 is going to be half V. So it is positive answer, which means obviously this will go this way, and it has half V speed. Okay, so this is the basically this was the aim of us to find the velocity first. Anyway, now so we just need to find the kinetic energy before the collision, and we can do that by using half m1 u1 squared plus half m2 u2 squared. And kinetic energy after would be half m1 v1 squared plus half m2 v2 squared. So this basically makes things much easier for us. Let me change the color. So then it will be half. The first mass is m, and this will be 2v whole squared. The good thing about this is that obviously you can add the signs, that's fine, but because of the square, it will just cancel out automatically, so it doesn't really matter, but we still add it. So this is going to be minus v whole square, okay? So we're going to get 4v squared. So this section will be 2mv squared. This will be basically plus 2 will cancel out with 2, so mv square, and negative will cancel out with because of that. So 2mv square plus 2mv square is 3mv square. Okay. Afterwards, what happens is it's going to be half, that's going to be m minus v whole square plus half 2m, and that's going to be half v whole square because we have found the velocity. So now it's going to be half mv square, and that's going to be 2 will cancel out with that, so it's going to be 1 by 4 mv square because 2 will cancel out with half and the rest is left. So half mv square plus 1 by 4. What's half plus 1 by 4? 3 by 4, I believe, right? 3 by 4 mv square. So this is afterwards. Now we just need to, find the loss of kinetic energy. So the loss of kinetic energy can be found out by simply doing kinetic energy lost will be kinetic energy before minus kinetic energy after. So it's going to be 3 mv square minus 3 by 4 mv square, which is, I think, 3 minus 3 by 4. Okay, what's that? 2.25. Okay, you guys, please help me with that. 3 minus 3 by 4. 2.25, 9 by 4. So that has to be this answer. Is that clear, everyone? Please let me know if you understand this. And if you don't, that's fine. Okay. So these sort of questions will be like repeated always. You should, be aware of that. Now, again, in the next question, you can write this down and then we can go forward, please. Okay. Okay, so now we're going to go towards this one. And this is, I'm going to give you this as homework. This is a very similar question. It's just different because in this one, they stick together and you need to find the velocity afterwards using momentum equation. And then when you find the velocity, you can do the total kinetic energy before minus afterwards. And that's how you're going to end up solving this. This is pretty easy compared to the previous one, but it is of the same feel, so you can actually do it yourself. All right. Now, going to this one. Now, if you notice, like this particular question basically was very, very long. And the reason why it was long, because we have to use so many equations. And the equations are easy. We already know the kinetic energy equation, but they take like, you have to add half and then mass and then square it and then subtract it, whatever. Basically, you can also use relative speed of approach and relative speed of separation, this concept. And if you apply this correctly, you can find whether the collision is elastic or inelastic. Okay, so I'm going to give you just one equation. You just need to remember that. If in case of elastic collision, you must always understand this, that whatever is on, like, you can remember it as u1 plus v1. All right, so these two, whatever these are, should always be equal to u2 plus v2. So if that is the case, like usually what we want is we want to remember this like u1 minus u2 equals to v2 minus v1. So this equation must be remembered. If they both are equal, that means collision is 100% elastic. Okay, in inelastic collision, basically this equation that I've written, u1 minus u2 equals to v2 minus v1, that will not be equal. So that's the thing we need to remember. The other thing I want to basically tell you in this, which is very important, that because the equation contain velocities, so their directions are very important. Okay, so do remember that. So we have to be direction specific in these equations, unlike, you know, in kinetic energy where there's a square to help us with. Okay, all right.
Sir, could
Now,
you explain it again, please?
yeah, what I'm saying is, Ayan, you just need to remember two equations in this, unlike one equation, which is this equation particularly. Okay, now if this equation on the left hand side, if the left hand side is equal to the right hand side, you call that particular collision as elastic. And if they don't basically are not equal, then you call that particular equation inelastic. All you need to do is you just need to be aware that these are velocities, so they are direction specific. So you need to put negative and positive signs according to their directions. Do you understand this? I'm going to apply this and you'll see.
Okay.
Now this equation is so easy because you do not need, like in these questions, let me write a note with a different color so you can also add that note. By using this equation, you do not need any mass. All right, so even if masses are not given, do not worry, you can use this equation to solve this. And that is why it is important to remember this. This is not an option, this is a must to remember this equation. Okay, is it clear? Now, first of all, let's look at how to apply this equation. And from this question, they've already, given us. So in this question says, two space, approach towards each other along the same line and blah, blah, blah. And they say they separate with this, which equation must be correct if collision is perfectly elastic, which means that we're talking about this equation, right? So I'm going to write this equation first. U1 minus U2 equals to V2 minus V1. So I'm going to write this equation. Then you need to apply apply directions. Okay, so let's suppose if somebody says I'm going to take this as positive, this as negative, which makes this as positive, this as negative, this as positive, this is positive as well. Is it clear? Now all you need to do really is add the values according to the signs in this particular equation. So what we're going to do is u1 is positive u1, so I'm going to write it this way. u2 is negative, so we're going to write minus u2. v2 is basically positive minus, and v1 is positive as well, but there was a minus already, so we have to write it this way. This is going to be u1 plus u2 equals to v2 minus v1. Can you see any equation that corresponds to this one?
D.
Yeah, so that would be the answer, and it's very simple to use if you remember this equation. All right, is it clear?
Yes, sir.
Again, I'm repeating this equation.
Yes, sir. Right.
Sorry, Suhail,
Nothing.
come again. Okay. So what I'm saying is this is not an option. You need to remember this equation because mostly this equation will be used, the kinetic energy equation that we've learned right here. Wait a second, right here is rarely used. Like this equation rarely used. The other one is used. Like the question that I skipped initially that was wrongly pasted here. The issue with this question was that the masses were not given. But the only information in this question was that it says that the spheres have a perfectly elastic collision. The moment I read this, I should remember it's u1 minus u2 equals to v2 minus v1. This is what we're doing. And then I'm going to apply some of the directions. So I said this direction is positive, this direction is negative, unless he has himself not given it. So that makes this one is positive. This one is just 0. This one is positive, and we do not know where it goes, right? Because it is elastic, so we're gonna assume where it goes. All right. So let's try to do this. So 6 centimeter would be just 6 and minus 0 because there was nothing. Afterwards, it goes to the same direction, so it's going to be 2. Sorry, it's going to be v2 minus v1 was just 2. So now 6 plus 2 is going to be v2, and that comes out to be 8 centimeters per second. So this is the answer. This is a very simple question. It's just that we need to apply the correct directions. Is it clear?
Yes.
Okay. Now similarly, yeah, so let's look at some of the variations that might be troubling in this sort of equation. All right, so because not always everything is green, so we need to also look at certain things like this. All right, so for example, in this question it says two sphere travels along the same line with the velocities v1 and v2, and they collide, and after collision their velocities are v1 and v2. Okay, whatever. Now it says which collision is not elastic, and when we read this, which means now we're looking to something like, we're going to write the equation here. I do this, so you can follow this if you like this method. I write both the things here, and what are we expecting? We are basically expecting that these two should not be equal. This is what our result should be. Okay. So I'm gonna basically, in this question, they have already given the negative and positive signs, so that's pretty good. And now we can add it up. Now the issue is, yeah, u1 is 2, and then u2 is minus and minus 5. Do not change the equation, just write minus where it belongs, equals to, on the other side, it's gonna be v2 is negative 2 minus negative 5. So what you get? You get, on this side, you get 7. And on the other side, you get
3.
3. Okay, so this is not elastic, which means they're not equal. Now, I would be a fool to just do this. Do not pick the first answer you see. And that's a big thing that I'm going to tell you. Now, let's check the other ones as well. So this is going to be like 3 minus 3, and that's going to be 6 and 6 and minus 0. So 3 and 3 would be 6 and 6. So these are elastic, so that could not be our answer. Then C is going to be 3 minus 2, and that's going to be 6 and minus 1. So that's 5 and 5. So that's going to be not our answer as well. Bas 5 minute. Acha na, wait. So it's going to be 5 minus 2, and that's going to be 6 minus 3. So luckily, all these are 3 and 3. So now you might be wondering, although we just got the answer in the first one, we just got the first answer is correct. Why didn't I pick it and I have to check it all? That I'm going to tell you in the next parts. First, you copy this, and then I'm going to tell you why that is so important. I just need 5 more minutes, please. Okay. Just hold on 1 second. Okay, you guys written? Should I go forward now? If you guys have no questions.
Yes, sir.
So this question, yeah. All right. So now look at this question. In this question, it says identical, and now it says the collision is perfectly elastic. So what we're looking at U1 minus U2 equals to V1 minus V2. Oh, sorry, it's bad. V2 minus V1. Anyway, so now let's see if that is correct. So in this one, it says V has a speed V. We're going to write this as positive, this is negative. So that means this would be initially positive, that is just 0. Stationary. To the right, this will be positive, negative, positive, negative, and that doesn't matter. Anyway, so let's check the first one. In the first one, this side will always be the same because the first condition is the same. So I'm going to just write it down here. So this is V, and that's going to be 0. V minus 0. V minus 0. So because initially they have just given one condition, unlike the previous question. Now in this one, now check this please. Afterwards, x, which is V1. So y is V to the right. So that should be positive, right? V minus 0. So V is equal to V. Now I get V is equal to V. I should be picking this answer. Okay, let's see if I'm right later on. Okay, then check this one, please. This is going to be, next time it's going to be V2 and minus V2. So this cancels out. This is like completely inelastic, 0. So one is V equals to 0. That's fine. The other one is V by 2 minus V by 2. So this is going to be V and V. Now again, if you see V and V, this comes as V and V. Now we have two correct answers. And now this is a trouble, right? Because an answer cannot have two correct answers. And now this would basically affect our end result. So let's see. In the last one, I'm going to check that as well. And I'm going to say it's going to be stationary minus, and that's going to be minus V. So that's also V and V. So this could also be correct. Only this one is wrong. Now what do we do? Now, once this situation occurs, and that is the reason why I want you to check all answers, because there can be multiple correct answers with this equation. So if there are multiple correct answers, use momentum equation to find the right one. And usually you will see the tip of this is usually these type of questions have a lot of space for working. So you will automatically see that that's not a very simple question. So what are we going to do? We're going to use M1U1 M2 U2 equals to M1 V1 plus M2 V2. Now we're only going to look at the, you're going to add this, and this to our equation. So initially, both masses have their identical masses. So let's call, they both have m mass. So let's write m. Initial velocity, initial was v because it was going to positive, plus that was 0. So that is our initial condition always. So for A, I'm checking. So m becomes 0, and m2, which is also m, goes to the right. So it becomes basically momentum in this one is conserved because you get mv equals to mv. So that should be our answer, but let's check C and D. For C, if you look at this, it's going to be mv equal plus 0, okay, equals to m, it goes to this, plus m, it goes to this. What? That's not fair.
Sir, why aren't we using the kinetic energy equation? Because momentum is conserved in inelastic collision as well.
No, momentum, because the equation might lead us, because we have already used that equation. This is a derivation of that equation. Do you understand? The reason is that I'm getting multiple answers from this equation. Even if I use kinetic energy equation, I'll get the same answer. Do you understand?
Okay.
So unfortunately, we cannot do that. Okay, right. Wait a second.
And sir, also in C, it's negative, so
Sorry, come again.
oh, nothing.
Yeah. So anyway, they're to the right. That's fine. Sorry, I used the other equation. Sorry, my bad. It should be negative v2. Now it's correct. So it's going to be mv equals to 0 because momentum is not conserved in this, so this could not be our answer. And then for D, it's going to be mv plus 0 equals to m minus v, and that's going to be m as 0. So now we're getting mv equals to minus mv. So that's not conserved as well. So this should not be the answer. Only A is correct. Do you guys understand now? So the idea behind these type of questions is that you need to check all answers, and that is why I'm insisting on this, that you should never leave any part unattended for this, because they might give you, and this is just luck that I got an A. But if, let's suppose this was D, then obviously your answer would be wrong in an actual exam if you don't check all the answers. Okay, so I hope you guys understand something out of this class, and we will see each other then